this short demonstration, we will have a look at the FLOEDA Bridge in Solid Edge. The FLOEDA Bridge provides an interface between Flow EFD and PCB board design. The FLOEDA Bridge is an optional module for Flow EFD, which allows for the import of very detailed PCBs into Solid Edge. You can use the FLOEDA Bridge to import thermal loads, to edit the layer stack up, to filter small components to simplify the design, make manual changes to the PCB and components, and finally transfer the design as an assembly to Flow EFD, where it can be positioned as required and can be used for a thermal analysis. It is started directly from the flow analysis ribbon. We start the import of an EDA file. FLOEDA Bridge can import designs in the following EDA file formats: Expedition PCB, IDF files, ODB++ files, ProStep, and IPC 2581. The dialog box also allows you to specify a default height for components that do not have the parameter specified. We can see the progress bar now and the design opens. The layers and components are listed on the left side now. When you select an object, the property sheet is displayed beneath the model tree. The model level defines how the board and nets will be modeled when transferred to Flow EFD, either compact, detailed, or explicit. The effect of this setting will be shown later. In addition, an relationship between percentage copper and thermal conductivity can be applied to better represent the thermal performance of the copper traces in layers. A thermal list can be imported to apply all the parameters in a single pass. A CSV file is used, which includes powers, resistances, and IC modeling levels. When this file is applied, the total power is updated and the components can be checked. A component can be selected and defined as simple, filtered, or as a 2 resistor. This can be, for example, defined here for the junction to board and junction to case thermal pathways. The power and ground nets selector allows selecting which nets are represented. All available nets found on the imported EDA board are listed here, and the relevant can be made available for the model tree. For this example, we set this selected trace to explicit. We can have a view from the bottom and from the top again, and see now also the selected component in the preview. If your design contains a lot of detail, you can simplify the design by filtering out individual or groups of components before transferring to Flow EFD. The Filters dialog box opens and we have several filtering options, such as component types and sizes, as well as filtering out the holes in the PCB. Filtered components are grayed out in the model tree and removed from display in the graphics area. You can add components to the board, for example this one, defined by the red marking, and the corresponding component details and positioning. The Outline Editor is a sketching tool which allows you to create and edit the board shapes as shown in this window. The current model in FLOEDA Bridge is now finally transferred to Flow EFD. We can select either compact, detailed, or explicit, as well as the previously mentioned analytical or empirical approach for the thermal conductivity calculation. The model summary dialog box is opened and we can see the progress bar for the transfer. The PCB is now available, the Flow EFD project is created automatically, and the computational domain can be seen and modified around the geometry. The project is set up for natural convection with the gravity vector shown on the screen. The materials are defined in the tree, all the heat sources and radiation sources from the components can be seen, and the 2 resistor part is created. Let's have a short look at the differences between the imported board as explained before. This is the compact one, showing the board as one single block. This is the detailed one with the different board layers, where each layer is a separate solid body. And here we have the explicit model, including the board layers. This one takes also into account the earlier selected detailed copper trace, including any connections through the other layers. The transferred model can now be used for a thermal analysis in Flow EFD. The model has been solved, so we can review the results. A plot of temperature can be seen here with a hotspot, and we can have a look at the different results for the compact one, for the detailed one, and the explicit model taking into account the earlier selected copper trace. The resulting temperature difference is also caused by the influence of the shown trace we can see in this plot. The calculation results can also be exported from Flow EFD to other post-processing software for analyzing and visualizing, or as loads for a FEA analysis software, or as a FEA text file including the shown parameters. With the Flow EDA bridge, it is very easy to compare and quantify different scenarios using Flow EFD for solid edge.